So there's just a couple of things to clear up after I rejigged some of the material to make things a little bit better in the notes. And that is just to describe briefly what the contrapositive is, or contraposition, and the converse as well. So in both cases, you start with an implication. So let me write something down. So this will be about contrapositive and the converse. And I just want to give a brief description of these. So in each case, start with a predicate of the form for all x, P of x implies Q of x. So the example I gave in the lecture is P could be I have seen the Fast and the Furious film X, and Q could be I like the Fast and the Furious film X. So this would say every Fast and the Furious film I have seen, I have liked. Be difficult to imagine liking it without having seen it, but anyway, that makes perfect sense as a statement. The contrapositive gives you a way of saying something equivalent. In the example I just said, what it would be is if there's a Fast and the Furious film I haven't liked, then I haven't seen it. Again, a bit of a strange way to put it, but you get the point. So the contrapositive is equivalent to this statement, and it is just for all x, you swap these over and put not in front of them. So not Q of x implies not P of x. Okay, let's just see why, even if we didn't have the 4x, just the implication P implies Q is the same as not Q implies not P. So the reason is the only time that this is false is when P is true but Q is false. In other words, if you want this to be true, then whenever Q is false, you need P to be false also. Right? That's this statement. So let me just say it again. So if we want P implies Q to be true, then it is I'll say it like this. Then whenever Q is false, we need P to be false also. Right? This will be false only when this is false and this is true. So as long as whenever this is false, this is also false, then we're going to get the equivalent statement. So P implies Q is equivalent to whenever Q is false, P is false also. Okay, and I'll write down an example of something like that in a second. Or perhaps I'll just do it now. So let's say, so the following, so e.g., the following says over the reals, every number that's not 0 has a multiplicative inverse, so something where you can multiply it by and get 1. Has a, let's call it a reciprocal, so just 1 over it. So if I say what every number x has a reciprocal 1 over x, so i.e. A number y where x times y equals 1. Okay. So how do I write that down as a predicate? I say for all x, and I'm over the reals, so as long as x is not 0, so x not equal to 0, that implies that there exists y such that x times y equals 1. Now, as long as x is not 0, then I can divide by it, and I can work out what y is. So let's write, this is a predicate of the right form, it's an implication thing. So let's write down the contrapositive. So the contrapositive is, so it starts the same for all x, and then I take not of this and then not of this, and I swap them over. So it's the same as not of, there exists y, such that x times y equals 1. That implies the not of this. Right, so I'll just write that down. If x is not equal to 0, then x is equal to 0. Okay. This does make sense. This is saying the only time that I can't find a y where x times y is equal to 1 is when x is 0. That is the same statement, and it's the right one. But I can even do a little bit more manipulation here, because I can move this not past the quantifier. So I can say, I can change this to a for all y, and then I change this to the not version of it. So x times y is not equal to 1. This implies x is 0. Okay? So let's check it still makes sense. Think of any real number. If it's the case that any other real number, when you multiply it, you don't get 1, well, the only time that happens is when x is 0. And that is the same thing as saying that you have a reciprocal. Right. So that was the contrapositive, and the process of changing P implies Q to not Q implies P is called contraposition. The thing not to confuse it with, so don't confuse with converse. So a converse statement, it starts the same. So again, starting with for all x, if we start with for all x, P of x implies Q of x, so anything of that form, then the converse is just where you swap the arrow over, or you swap the two equivalently, you just swap the two predicates over. So then the converse is, for all x, q of x implies p of x. Right? So let me just go back to the statement that we had about the real numbers. So e.g., if we start with for all x, if x is non-zero, then I can find a y such that I multiply it by x and I get 1. So that was what we had before. Then the converse is saying that whenever there exists a y such that x times y is 1, then x must be not equal to 0. So for all x, there exists a y such that x times y equals 1 implies x not equal to 0. This one happens to be true. So because if you multiply x by anything, you'd get 0. So if you know this statement is true, then you know x has to be non-zero. But in general, it's not going to be. So so this happens to be true. But let's take an example where it isn't. So, however, if I take for all x, so we're still working over the reals, x squared is bigger than or equal to 0. Sorry, let me do this better. For all x, x bigger than or equal to 0 implies x squared bigger than or equal to 0. So this one's true. I mean, obviously if you take any number at all, real number at all, and square it, if it's negative or positive, you still get something that is a positive square. But the converse here is not true. But the converse is not true. So what's the converse? So the converse here is for all x, just swap these things over. So x squared bigger than or equal to 0 implies x bigger than 0. This is saying every time you take a number whose square is positive, then the number had to be positive in the first place. This is not true. And it's a good opportunity to remember that if we want to show that something is not true, we need, that's a for all kind of thing, we need to find a counterexample. So we need to find some element that means that this is not true. So when is that going to happen? It's going to happen when this is not true, but this is true. Well, this is always true, so if I just take a negative number, so for example, x equals minus 1, this is less than or equal to 0, but x squared equals 1 is bigger than or equal to 0. So those are the only two things that needed to add. It gives a little bit of practice, again, with taking negatives of predicates. But yeah, that is that. Thank you.